It's a wonderful day, students! Just another day of learning things around you explained by science. And for today, our featured topic is all about the processes along the plate boundaries. And once again, of course, here are the objectives that we will be covering for this day. So the first one is you should be able to explain the processes happening along the divergent boundaries, and of course to identify the landforms associated with the divergent boundaries. And next, you should be able to explain the processes that occur along transform fault boundaries, and as well identify the landforms associated with the transform fault boundaries. And lastly, you should be able to explain the geological processes that occurs along the plate boundaries. So previously on your live discussion with me on week 3, you were able to identify the 3 types of plate boundaries, where the first one is the convergent boundary, the second one is the divergent boundary, and the last one is the transform fault boundaries. Today in this live, we will be uncovering the processes that happens or occurs along those plate boundaries. And if you could remember, mountains, volcanoes, and earthquakes all occur at the edges of the plate boundaries, which actually gives us a hint that plates do really move, and that there are different mechanisms and several processes and activities happening along the edges of the plate boundaries, which leads to the formation of the 4 mentioned geological features. So, what are those processes that could lead or give rise to the beautiful sceneries that we see in our nature? So, let us start with the first process, which is the process happening along the convergent boundaries. So once again, convergent boundaries are boundaries where you can find the colliding plates. And we have actually 3 different types of convergence under this kind of boundary. We have the continental-continental convergence, continental-oceanic convergence, and oceanic-oceanic convergence. So let's have the first type. Under continental-continental convergence, so 2 continental plates are actually colliding as what the name suggests. Now, since both of them have the same densities, same characteristics, of course, none of them will give up. Instead, they will smash one another and they will push towards one another upwards, forming mountain ranges. And one of the most amazing products of this type of convergence is the Himalayas group of mountains, which extends 2,400 kilometers along or passing through the nations of India, Pakistan, Afghanistan, Nepal, Bhutan, and China. Now, next type of convergence is the continental-oceanic convergence, by which continental crust and oceanic crust collide and form volcanoes. Now, this is where the subduction process happens, wherein the denser and cooler oceanic crust goes beneath the buoyant continental crust and goes directly into the mantle, where melting happens there, and as the magma goes up, of course, it would erupt and form volcanoes at the surface of the continent. And down to the last type of convergence, we have the oceanic convergence, where 2 oceanic plates are actually colliding, causing volcanoes, specifically the underwater ones or the submarine volcanoes, and the what we call trenches. So in this kind of convergence, since both of them are oceanic crust, so which one would subduct? So the one that is much colder, much denser, and much older will subduct beneath the other. So the oceanic crust goes into the subduction zone, going into the mantle or melting happens. And of course, as the magma goes up, once again, it would form underwater volcanoes or volcanic arcs. And due to the high pressure that the subduction process at the convergent boundaries is causing, deep depression is formed, which we refer to as the trenches. So what are trenches? An oceanic trench is a deep and narrow depression on the sea floor. So do you know what is the world's known deepest oceanic trench? Well, in the Pacific Ocean, just somewhere between Guam and the Philippines, lies the Marianas Trench. And at 35,814 feet below sea level, the bottom is what we call the Challenger Deep. And this is actually the deepest point on Earth. In fact, to put it into perspective, just think about the Titanic, which was found 12,600 feet below the surface of the Atlantic Ocean. And that is nearly 2.4 miles down. And the Challenger Deep is nearly 3 times deeper than that. So just imagine the diversity of the sea creatures that are yet to be discovered there. You could just play with your imagination. Once again, those were the 3 types of convergence and processes along the convergent boundaries. Now let's talk about the second type of boundary, which is the divergent boundary, and what are the processes happening along this kind of boundary. So under divergent boundary, we have 2 types of divergence. First one is the continental divergence, and the second one is the oceanic divergence. So let us have the continental divergence first. So as 2 continental plates tear apart, what do we expect to happen? So it is actually creating a fissure and exposing the magma in the asthenosphere, and the magma will of course find its way up across and erupt, forming volcanoes. Just for an instance, the Mount Kilimanjaro here is a volcano formed from a continental divergence. And in this example as well, you could also see that lake waters starts to fill in the reef valley. And the second type of divergence is the oceanic divergence, or what we call the seafloor spreading. In here, the mechanism of the diverging oceanic plates is driven by the convection current. In other words, the plates are being pulled into the direction of the conversion or in the direction of the convection current. Now, the gap between the diverging oceanic plates forms a mid-ocean ridge. Okay? And that gap would be filled by magma. And as it goes up and forms underwater, as it goes up, it will actually form underwater or submarine volcanoes. Now, as the underwater volcanoes erupt, the magma will solidify and now forming new ocean floor. And this is actually the main reason why oceanic crust is much younger than the continental crust, because the older oceanic crust undergoes subduction process at the convergent boundary, of course, where it melts there and go into the mantle, and of course, new ocean floor will be formed at the divergent boundary, as the melted materials, of course, goes up and solidify. Alright, whereas the continental crust just keeps on growing and growing and getting older and older. Now, moving forward and down to our last topic, let's have the process that happens along the transform fault boundaries. So, transform fault boundaries are formed when two plates slide past one another. And this actually creates massive and destructive types of earthquakes. So as you can see in the illustration, for an instance, the San Andreas Fault has created a boundary between the Pacific Plate and the North American Plate. And this is due to their opposite relative motion as they slide past one another. Now, take note that all transform faults are strike-slip faults, but not all strike-slip faults are transform faults. Meaning to say, all strike-slip faults that are found at the edges of the plate boundaries are considered to be transform fault boundaries. But those strike-slip faults that are found within the plate, or what we call intracontinental, are not considered as transform fault boundaries. Alright, so now with all that you have learned with this lesson or with this discussion that we had, let us now try to answer a few questions. So the first one is, why is oceanic crust much younger than the continental crust? Why do you think so? Well, the oldest continental crust is 4 billion years old. And the Earth, take note, was formed 4.5 billion years ago. So just imagine how ancient the continents are. Whereas the oceanic crust is just 260 million years old. Sounds old, but compared to the continental crust, continents are way much more older than the oceanic crust. And this is actually due to the subduction process that the oceanic crust undergoes, where the older oceanic crust descends to the mantle and melts to become new ocean floor. In other words, oceanic crusts are actually being recycled, whereas the continental crust just keeps on growing and growing. So let's have the next question. So where can we find the youngest oceanic crust? Where do you think so? Oceanic crusts are actually found at the mid-ocean ridges because this is where the new oceanic crusts are being formed or being born, whereas the older oceanic crusts are found away from the mid-ocean ridges. So once again, the youngest oceanic crusts are found at the mid-ocean ridge. Alright? Now, for our last question, question number 3, what is the importance of the subduction process? So we keep on talking about subduction process. So what do you think is the importance of this kind of process? Well, subduction process is actually very significant because no ocean floors or ocean floor will not be renewed if not with the subduction process. And as well as the volcanism, it wouldn't be possible if not with the subduction process. And the geologic activity of subduction zones is enormously beneficial to all mankind and to Earth. In fact, dry land exists only because of subduction. And continents are born from the destruction of the oceanic crust. So the magma produced as subduction zones hardens into granite. And you know that granite is actually the bedrock of all the continents. And once the continent has been created, continents will keep on growing above sea level through further subduction. And almost all of the important natural resources are derived from the subduction process that we have, like oil and natural gas, which could be developed in the thick organic sediments that accumulate around the plate boundary, as well as the volcanic rocks, which release nutrients as they weather, forming some of the most fertile soils on Earth. So see how much the subduction process is really significant and beneficial to all mankind and of course to our Earth. Alright, so for now, to wrap it all up, so let us recall the processes and land formations that happen along the edges of the plate boundaries. So once again, we have the convergent boundary. And under convergent boundary, what are the three types of convergence? So first we have the continental convergence. Next, we have the continental hook to oceanic convergence. And lastly, we have the oceanic convergence. Now, what are the landforms associated with this type of convergence? So under continental convergence, it could lead to the formation of the mountain ranges. Next, under continental oceanic convergence, this type of convergence could give us or give rise to the volcanoes. And for the last type of convergence, this could lead to the formation of the underwater volcanoes and trenches, of course. Next, under divergent boundary, we have two different types. And these are the continental divergence and the oceanic divergence. Wherein under divergence of continents, we could form or it could form reef valleys, volcanoes, lakes, rivers, and even ocean basins. And under oceanic convergence, it could actually lead to the formation of mid-ocean ridges, volcanoes, and also new oceanic floors. And lastly, we have the process under transform fault boundaries. And transform fault boundaries could actually lead to the occurrences of very massive and destructive earthquakes, as well as to the formation of strike-slip faults. Alright, so that ends our discussion for today. So see you guys next week on our next Ag Amazing discussion.